So this is an example of one of the big five equations that will have to be used, but with the vectors that are not one-dimensional, they're two-dimensional. We got west going on, and we have got south going on. So I'm just going to make a list here of the given information. We have the beginning velocity at 4.0 meters per second west. They turned the corner and are now going at 4 meters per second south. And they accomplished that over a time of 3.0 seconds. So they ask us for the average acceleration. So actually, it's not really the big five. It's actually just the definition of average acceleration. The formula for that is the change in velocity, so v2 minus v1 over delta t. So you may think that, well, it's just 4 minus 4 is 0, and get your answer of 0, but that is not the answer. You cannot just do 4 minus 4. That would just be regular arithmetic, but we have to do vector arithmetic, which usually means we have to draw triangles. So since these directions are perpendicular to each other, I'm just going to do it by hand. I'm not going to go with the online vector calculator. So I'm going to start by drawing 4 meters per second south. That's v2. And then it's going to be minus, here, let me, this is the equation we're looking at. So I've done the 4 meters per second south, and now I've got to do minus 4 meters per second west. So I'm going to change minus to plus, and I'm going to change west to east. So I'm changing vector subtraction to vector addition of the opposite direction. So I'll add that in the east direction. Okay. So I'm doing the tip to tail method, actually, method 1, method 1 from the notes, which works pretty well, actually, if the two vectors are just perpendicular to each other, because then we can just use the Pythagorean theorem. If they're not perpendicular to each other, then we're looking at cosine law and stuff like that. In that case, I would probably prefer methods 2 or just using the online calculator. So the black line there, that's going to be the result for v2 minus v1, which I'll actually label as delta v. Right? Delta means final minus initial. And I also labeled the angle that I want to find out as well. The angle is 45 degrees because it's an isosceles triangle, right? Both sides are 4. So I can go ahead and just declare that. I'm not going to really do inverse tangent. It's just going to get me 45 degrees. And for the magnitude of the hypotenuse, I use the Pythagorean theorem. So it would be the root of 4 squared plus 4 squared. So it'll be the root of 16 plus 16, so the root of 32. So let me calculate that in my calculator. So that's 5.7, or I'll keep an extra digit just because we're not done yet. 5.66 meters per second. Okay, so going back to my equation, my next step, in my numerator, I've calculated the answer to the numerator to be 5.66 meters per second in the direction of south 45 degrees east. So that is the direction of the acceleration. That is what's going to allow this person to turn. This is going to be divided by 3 seconds. And in my calculator, I end up with, to 2 sig figs, 1.9. This is going to be meters per second squared. It's acceleration, so it should be meters per second squared. But you may also notice I put the units in my steps, so that confirms that I'm getting meters per second squared, because I got meters per second in the numerator and seconds in the denominator. And the direction is just going to be preserved from the numerator. So that is the average acceleration. All right.